Okay, so welcome this Saturday morning to this machine learning workshop. So my name is Dr. Tan Chin Hon. I'm a deputy head with the Department of Industrial and Systems Engineering and Management at NUS. And so today what we hope to do is that we hope to share with you some basics about machine learning. So I think the best way to kind of motivate this is just to share one of the projects that our students have done. Oh yeah, and before I continue, so what we can do is that along the way, if you have any questions, feel free to just type your questions onto the chat box. So this is how I conduct my lessons as well. So any questions that pop up along the way, feel free to just type them into the chat box, and then as and when the time is appropriate, then I will address them. Okay, so don't worry about interrupting the flow of the whole workshop. I think that's the nice thing about Zoom. So any questions, just type it in and then I'll take note of it. So once we reach a good time, then I will just address them. Okay, so feel free to do that. So let me just very quickly share with you one project that our students have done, and then and that will be a good motivation for what we're going to be sharing with you today. So, this group of students, they were actually attached to one of the food manufacturing plants. And so basically this manufacturer, they produce a lot of food products. One of it is going to be sausages. And so they actually have a conveyor belt over here where essentially the sausages are going to move through the conveyor belt. And then as they move through the conveyor belt, what happens is that there will be staff along the conveyor belt to detect those sausages that were defective over there. So if you were to pick up your packet of sausages from the supermarket, it may not be evident to you. But in the manufacturing process, there are going to be products that are going to be defective. So not all products are going to come up as a good sausage over there. Okay, and so why you don't see these defective sausages is because during the manufacturing process, there are already staff along the way to pick them up and then prevent them from being packed and then being shipped to the supermarket over there. In fact, it's not just for food products, but if you look at all the consumer products that you buy, these days the defect level is very low. So very often when you pick up the item from the store, be it food products, be it electronics or so on, very often the product is going to be serviceable. It's going to be something that is working. Okay, and this is because most manufacturers have a very rigorous way of detecting for all these defects over there. So, but what happens over here is that for this manufacturing plant, the detection of the defective sausages, it's actually done manually over there. Okay, so it's done manually by staff who are just going to observe and then pick up those that are defective. So I'm sure you can see how that's going to be done. So if it's defective, it's basically just send back to the start if it's and then you will grind it and then so that you will be remade into a good sausage over there. Okay, there are going to be issues over there, which is that it's going to be very labor intensive, and it's also going to be quite a boring task for the employees over there. Okay, and at the same time, humans are going to be prone to errors as well. So this is where when the student went in, basically the job was to analyze this problem and then look for possibilities to kind of address it. And so one straightforward way of addressing this would be to, can we get a machine to perform this task rather than to get a human to do that over there? Okay, and so what they did was basically they basically set up a system where they put a camera above to capture the video feed over here. And so basically, if you know, a video feed is essentially just a series of still photos, right? And so basically then with each of these photos, they will then be able to analyze it. Okay, and so from here they can, basically we just need to train the machine to know if I see a sausage over here, is it a good sausage or is it a defective sausage over there? Okay, and so basically they pull out some machine learning libraries to implement this, and then they go ahead to implement this for the company to demonstrate what this technology can potentially do for them over there. Okay, and so the company liked it. And so these types of things is not too difficult these days because there are a lot of libraries that you can actually pull out to go ahead to implement this. Okay, and so I hope this gives a good background as to the usefulness of image classification. So this is a problem where we refer to as image classification, where if we show a computer image over there, we want it to classify it as, is it a good sausage or is it a defective sausage? Okay, so I see on the chat there are no questions, so I'm assuming everything is okay. So just a quick note to those who have just joined us. Along the way, if you have any questions, feel free to just type them into the chat box. And as and when it's appropriate, then I'm going to address them. Okay, and with that, let me just give you a more formal introduction into what the image classification problem is. And so basically, we just show the computer a image over here. Okay, so I have a image over here. And basically, the task given to the computer is, after I've shown you an image, I want you to classify it as one of n possible categories. Over here, I have a problem where there are 10 possible categories. Is this an image of a t-shirt? Is this an image of a trousers, pullover, all the way to an ankle boot over there? Okay, and so for a normal human, we look at this, shouldn't be difficult to identify that this is going to be an ankle boot. Okay, the problem over here is how do we train a machine to be able to do this rather than to get a human to do that over there. Okay, and this is going to be something that's going to be very useful to the companies because it can potentially result in a lot of cost savings. So let us quickly just go back to the previous example, right? So previously what happens is that we need at least one staff on each conveyor belt to monitor to make sure that there are no defective sausages over there. Sometimes you might potentially even have more than one staff on one conveyor belt. But if you were able to train your machine to automate this process, then what you could do is you could actually have one staff to manage 4 or 5 different conveyor belts over there. Okay, basically, the staff doesn't have to keep watch at all the conveyor belts. All the staff needs to do is react to the situation where a defective sausage is identified. Okay, and so under that situation, rather than one staff to one conveyor belt, you could have one staff to, let's say, 5 conveyor belts over there. Of course, the staff to conveyor belt ratio would then depend on the defective rate and so on. Okay, and so that will not be machine learning, right? That will be in terms of how do you then kind of manage these operations over there. Okay, if the defect rate is very low, then you can have one staff to potentially 10 conveyor belts because there are very small incidents that the staff needs to attend to. But if the defect rate is high, then you might need to have one staff to every 2 or 3 conveyor belts, simply because the staff is going to be very busy in terms of picking up all these defective sausages over there. Okay, but I've digressed. That is a topic for another point in time over there. Okay, but so I hope I've given you a good idea as to what the image classification problem is and also why it is potentially going to be very beneficial to companies and why companies are going to be interested in that. Okay, so good time to just do a quick pause. Do we have any questions up to this point in time? Or if there is, just feel free to type it into the chat box and I'll be happy to address them. Okay, nothing. So far, so good. So let's proceed. Okay, so how does this classification process actually work? So what we have in the center is going to be a classification model. So this is going to be our computer over here, which is going to try to perform the classification. So what we're going to do is that we're going to feed our computer a image. And after we feed the computer the image, we want the computer to come up with a score for each of the possible categories over here. Okay, and so after we feed this image to our computer or classification model, the classification model will say that the score for a t-shirt for this image is going to be 3.42, and the score for trousers is going to be 8.56, and so on, all the way to ankle boot, which has a score of 37.08 over there. Okay, and so how will the computer classify this image over here? So the classification logic is going to be very simple. So since ankle boot has the highest score out of these 10 categories, so I'm going to say that this image is most likely going to be an ankle boot over there. Okay, and in this particular case, it's going to be correct. Okay, and so this essentially it's how that classification process is going to be done. This is going to be probably the most common way that's done. We feed an image into our classification model. The classification model gives us a score for each of the categories. And then based on the score, we can then identify which is going to be the most likely category that this image actually belongs to. So I think this should be fairly straightforward. Any questions or clarifications? Okay, and so I have a question over here. Let me see. I do not know if you are able to I see that it's a direct message to me. I do not know if it's a setting or whatever, but if you have a questions, feel free to just share it with everybody so that they can see. Or if you want to share it with me directly, that's fine as well, but I will share it with everybody. And so that's a good question. How does the model come up with the score over there? And that is what we're going to go into later on. So in this workshop, I will illustrate to you how we can actually how you are going to actually be able to implement this, and we will get to that shortly. Okay, great. That's a good question. So I can see that you guys are eager to find out more. So let's move forward. Once again, along the way, any questions? Feel free to just put it in. We have another one over here. Is there a scenario where more than one category has an equal score? It could potentially be, but under that situation, what happens over there is that if two categories have the same score over there, then your classification model is just going to say that these two are equally likely to happen over there. But in many cases, the scores are going to be somewhat different, and so they're not going to be equal over there. Okay, but if they are equal, then a straightforward way will be to just say that randomly choose one of the two, or potentially you could output to say that, hey, there are two possibilities over there. Okay, there are different ways that you can go about to implement this. For that, the consideration is essentially going to be what does the decision maker want to know over there? Okay, does the decision maker just want to have one prediction, or does the decision maker might be concerned that if there are more than one predictions, then we want to highlight that? Okay, and so under that situation, you may not even just want to report that the ankle boot is our most likely prediction. You could potentially say that ankle boot is the most likely, but under this situation, there's a reasonable potential that it could be a sneaker or it could be a sandal as well. Okay, which brings us to the next question over there is how can the score be negative? So from a mathematical perspective, later on when we go through the math over there, then we can take a look to that should explain why the scores can potentially be negative. Okay, it basically depends on how you implement it. So there are different ways that you can implement it. So if you put in certain rules, you can enforce that the scores must at least be non-negative. That means at least 0 over here. Here I use a very general rule where basically we don't add in that restriction, and so there's the potential for a negative score, that's all. Okay, but later on, once we run through the math, I think we will be able to explain what type of restrictions do you put in such that the scores will be non-negative, or what sort of things can you do to allow for negative scores over there. Very quickly, what do negative scores mean over here? So you could just take it that the higher the score, the better. And so the more negative the score, the worse it is over there. Okay, and so the interpretation over here is that This image is very likely to be an ankle boot, but there's a reasonable potential that it could be a sandal or a sneaker over here. But we can tell you that with very high confidence. So in engineering and in math, we don't like to say things for sure. So we don't like to say for 100%, but with very, very high confidence, it's unlikely that this is going to be a coat or a pullover or even a shirt over there. Okay, and that makes sense as well, right? I mean, intuitively as a human, you could realize that, okay, this is an ankle boot, but it's probably, it's fairly similar to what a sandal or a sneaker is going to look like. But this totally doesn't look like a coat or a pullover over there. Okay, and so that's kind of how you go about to interpret it. Okay, great. Those are good questions over there. I think as we go through the math behind how these scores are computed, then a lot of other things are going to be a lot clearer over there. So meanwhile, other questions, feel free to just put them in. But before we can even compute the score, the question over here is how do we actually get our computer to read in the image over here, right? If you are familiar with computers, you realize that they actually just take in binary numbers, right? That means either a 1 or a 0 over there. And if I take an image, how do I convert an image into a score? That is pretty difficult, right? It's not immediately clear how you're going to convert an image into a score. But if I gave you numbers over here, which is what computers can read, and then once I have numbers, it is easy to convert numbers into scores, right? Basically, I just apply some function. Any mathematical function you have, what it does is that it takes in numbers and then it shoots out another number over there. Okay, and so the first issue that we need to tackle is how can we actually change our image into a series of numbers so that our classification model is able to input it, read it, and then apply functions on it to convert it into a score over there. Okay, and so this is another image over here. So this is probably going to be a pullover, and so this is a very small image. But if I was to just blow it up, what I did was basically I just convert this. This image is actually made up of 28 by 28 pixels, which is essentially a total of 784 pixels. So this image over here, basically I break it up into 784 individual cubes over there, or squares, and each pixel over here is just essentially going to be described by a number. So if your number is 0, then it's a very small number. Then we just we say that it's going to be yellow color. And the bigger the number, then we move towards the green color over there. Okay, and so that's why you see numbers that are a pixel with value of 255 is going to be a dark green. Let's say you have pixel values of 110, it's going to be between yellow and green over there. The larger the number, the darker the shade of that color over there. Okay, and so this is how we essentially just convert an image into a series of numbers. So I have an image over here. Basically, I cut it up into 784 chunks, and depending on the color intensity, I assign a number value towards it. And so what I've done over here essentially is I've converted my image into a series of 784 numbers. And once they are numbers, then basically they are numbers that the computer will be able to understand. And once they are numbers, they are going to be numbers that we are able to perform mathematical operations such that the result is going to be just another number over there. I hope that's clear. Any clarifications required? Okay, great. So if not, then basically this is what it's going to look like. So we have an image over here. We converted it into 784 numbers, and then we feed it into our computer over here. And basically then the computer will just do some mathematical operations. And what happens is that it basically just churns out 10 numbers over there, which is essentially the scores of each of the categories based on this image over here. Okay, and the one that has the highest score, we're going to use that as basically our predicted image. Okay, and so let us now very quickly just run through how the numbers are going to be computed over there. Okay, and so how this is done, there are different ways that you can do it. The most common and probably the one with the highest performance today is going to be based on the artificial neural network. Or in fact, people these days, they use a deep learning network, which essentially it's a neural network with a lot of layers over there. Okay, so let's just give a very quick introduction into what a artificial neural network is going to be. So there are going to be neurons. I represent them via these circles over here. And these neurons are going to be connected to each other. Okay, and that's going to be represented by these black lines over here. For this first column, I'm going to call it the input layer. And this second column, I call it the hidden layer. And the third column over here, I call it the output layer over here. Okay. And so what happens is that the input layer is just going to take in the inputs. So this is going to be the image, the 784 numbers that we're going to feed into our image classification model. And then there's going to be outputs. This output over here is going to be the score. What is the score of, let's say, a ankle boot based on this image, based on the inputs that I put in over there? Okay, and there are going to be weights as well. So to demonstrate what the connection weights are, let's give an example. So let's say in the input layer, I have two values over there. Okay, so rather than using 784 numbers, let's go with a very small one so that we can run through the specific calculations. So let's say I have two input numbers, 5 and 7 over there. Okay, and I'm going to have my connection. So I've mentioned to you that the neurons are connected, and each of the connectors over here is going to have a weight associated with it. And so for this connector over here, there's a weight of 1 associated with it. And for this connector over here, there is a weight of 3 that is associated with it. Okay, and on top of just the connection weights, there's also going to be a bias value as well. Okay, and the bias value is going to be associated with each of these neurons in the hidden layer over there. Okay, and so this neuron in this hidden layer over here is going to have a bias value of 2. And given the inputs, the connection weights, and the bias value, we are now ready to calculate, to perform our calculations over there. In particular, the value of this neuron over here is just going to be equals to 5 multiplied by that connection weight, that is 1, plus 7 multiplied by 3, this connection weight over here, plus this bias value, which is 2 over there. Okay, and so that's how you end up with a value of 28 for this neuron over here. Okay, very quickly, let me just run through that again. How we get the value of this neuron is by just taking all these inputs over here, and we multiply them by their respective connection weights. And then finally, we add the bias value of this neuron over here to obtain this weight, to obtain this neuron value over here. Okay, so this is how I get the 28. So very quickly, we can just run through another example. So let's try and get the neuron value for this neuron over here. Okay, in this case, the connection weight, the weight of this connector is going to be 2. And let's say the weight of this connector is going to be 0 over there. And then the bias of this hidden layer is going to be minus 11. Okay, and so under this situation, the calculation is going to be the value of this neuron is going to be 5 times 2, that's 10. And then after that, plus 7 times 0, so that's 0. So we have 10 minus 11. This value is going to be minus 1 over there. Okay, and so I hope this is where you can see how a negative value can actually potentially emerge out of, let's say, your classification model. Okay, but just now we had a question, how can the score be negative? If you're familiar with neural networks, you might be aware that one way of implementing neural networks is that they will convert all negative values into just 0 over there. Okay, so that is frequently used. it doesn't mean that you have to always do it. Okay, but if you choose to do that, then under that situation, this neuron over here is not going to be -1, but is then going to be 0. Okay, and so if you have that additional implementation over there, which once again, it's often used, but it doesn't mean that you have to do it. Under that situation, then your values are all going to be non-negative. That means you will never see a negative scores over there. Okay, and so whether to enforce this non-negativity or not, it depends on the problem that you're looking at. Okay, so it's not immediately clear. So under certain applications, enforcing it to be non-negative can result in better outcomes. But in certain situations, it might be better to just let it be negative rather than to enforce the non-negativity over there. Okay, so there's a lot of flexibility in terms of how you want to implement it. Okay, but for image classification, enforcing the non-negativity rule actually is something that commonly happens. Okay, but once again, I have to stress that it doesn't mean that you always have to do it. Okay, there are ways for us to check to see when it works and when it doesn't work over there. Okay, but for this particular example, I'm enforcing it because it's going to work well for the example that we are going to be showing on later when I get you guys to work on the example. Okay, so I hope that is clear. And once we have that, finally, we will just want to compute the score at the output layer over there. And so how we're going to do that, it's once again, we're just going to base it on the weights and the biases over there. Okay, so suppose that the weight of this connector is 0.3, the weight of this connector is 0.5, and the bias is 0 over here. Then this value over here essentially is just going to be 28 multiplied by 0.3 plus 0 multiplied by 0.5 plus 0. That essentially works out to be 8.4 over there. And so this essentially it's how the image classification machine is going to convert your series of numbers over here into a score at the end. Okay, but for the one that we look at just now, it's a lot bigger, right? We had actually 784 inputs, and then later on, we actually have 10 outputs rather than just one output over there. Okay, and so the only difference is basically in terms of the skills. But in terms of the logic, in terms of what goes behind, what goes underneath the hood, basically that's all there is to it. Okay, once you know your connection weights, once you know your biases over there, given any input, you will then be able to compute out the output score over there. And so that's why I have a comment over here. Basically, your classification model is going to be defined by your connection weights and your biases. Once these are known, given any inputs, you will be able to compute out your image score or your output score. Okay, a good point in time to just do a quick pause and check if there are any questions. Okay, I will probably go on for about another 10 more minutes, and then later on we can take a quick break before we come back and do our hands-on exercise over there. Okay, but let's see. We have the question over here, which let me just share with everybody. And so that I can read it as well. Why is the bias value added at the top but minus away at the bottom? And that's related to probably the second question, right? How are the bias values determined? In fact, the question can be more broadly said to be, how are these weights and bias values actually determined, right? And that is what we're going to go into next. So let me just very quickly just run through that since we're already on that. Okay, and so how do we actually go about to identify the weight and bias values? So let me just quickly run through what is going to be the typical approach towards coming up with this model over there. So generally what happens is that you are going to need a significant number of image data over there. So we begin with, let's say we have 70,000 images over there. So I have 70,000 images of different fashion items. So I have maybe 7,000 images of a t-shirt, 7,000 images of trousers, 7,000 images of pullover, and so on. Okay, so I have a big number of images over there. And given those big number of images, what I'm going to do is that I'm going to separate them. So for example, I will separate them into 60,000 images that I'm going to use for training, and the remaining 10,000 images I'm going to use for testing over there. I'll get to what these actually mean over there. Okay, and so what we're going to do is that based on our 60,000 images, our training data, we are going to figure out what are the weights and bias values that are going to fit them well. Okay, and so this is where, given that we know the input layers, then given that we know the output layers over there, we can then try for different weights and bias values, right? So I can see that, okay, given this combination of weights and bias values, how good were my predictions? And then if I was to change for a different set of weights and bias values, how good were the predictions over there? Okay, and so based on those 60,000 images, I would then be able to find a set of weight and bias values that seem to do the classification well over there. Okay, and so those are the weights and bias values I'm going to use to build my classification model. But are those going to be good weight and bias values to use over there? It's a bit like we are cheating, right? Because we kind of know the answer, and then we reverse engineer to figure out what are the weights and bias values over there. So this is where the testing data comes in over there. Okay, and so this is where the remaining 10,000 images that we did not use, we are going to use this remaining 10,000 images to test the classification model that we had. Okay, and this is where we can then verify whether if indeed these weights and bias values were good in terms of performing our classification or performing our predictions over there. Okay, and the assumption over here is that if our model was able to do the prediction well for a large number of image data, for 60,000 images over there, if we were to feed it another new 10,000 images that he has never seen before, it should be able to predict those images well as well. Okay, and so this step over here is based on this assumption that we are saying that we are going to use the weights and bias values based on the based on those 60,000 images that we have over there. But we don't just take this assumption blindly. What we do is that we test it with the remaining 10,000 images to verify that this assumption over here is indeed true. Okay, if it's not true, then we need to go back and try to figure out what went wrong over there. Okay, so that will be beyond the scope of this workshop. But in many cases, the assumption is going to be valid, and then basically you say that, okay, then this is going to be a good model that I can use subsequently over there. Okay, and when we talk about machine learning, this is essentially what we are doing over there. Basically, we are feeding our machine a lot of images, 60,000 images over there. And based on this 60,000 images, the machine has figured out what are good weights and bias values to use. And recall, these weights and bias values essentially define our classification model. And finally, basically, we just use the testing data to verify that indeed this model is going to be working well. Okay, we have one question over here. Besides determine the bias values, what else will testing and training decide over there? I think that of course in the most basic level, you can think of this training and testing. It's just the training is for you to figure out what is a good set of weights and bias values to use. And the testing essentially is to verify that indeed this is fit for purpose. If you use them on a new set of data, it's going to give you reasonable performance over there. Okay, that is the key thing that this training and testing is going to do. There are other things that you can look into for the finer details, which is that it's not just a matter of that is it fit for purpose or not. Is the accuracy going to be 90%? Is it going to be 80%? Or is it going to be 70% over there? So very quickly, let me just come back over here, right? So if you were to look at the example I begin with, so how they actually obtained that they were able to achieve a 95.8% classification accuracy is by making use of that testing data. So they tested and then they realized that in 95.8% of the time, this is going to be accurate. So that is a good question because this is where machine learning ends, right? Basically, machine learning just tells you that, okay, this is a good model. The accuracy is 95.8% over there. But then the manager needs to worry about, so what about that 4.2%? How are we going to address it? Okay, and so then that depends on what are the consequences of packing a wrong sausage over there. Okay, and so then you got to weigh the benefits and the costs. So that is going to be beyond machine learning. So that's where our students will have to apply their operations management, their applied probability type of methodologies to address that issue over there. Okay, so good question, but I hope that gives you a better sense of all that. Okay, and so this is where I think machine learning is good, but it is one part of this whole solution process. So in terms of getting solutions to real world problems, there's that whole process over there. Okay, great. Let me just fast forward. Okay, and so with that, let me see. Okay, and so the next slide over here is where basically just to highlight to you what we're going to be doing later on. So recall just now that we actually have an image that have 784 numbers rather than just two numbers, right? So but that's going to be two. I mean, it's still possible to implement it in Excel, but for this workshop, I do not know everybody's Excel background, so I decide that let's do something simple. So so what I do is that let's convert this 784 images into essentially just 16 numbers rather than 784 numbers. Okay, and then based on that 16 numbers, so that will be my input layer over there. I will then go on to a hidden layer. So I'm just going to use 12 nodes in my hidden layer. And then later on at the output layer, I will output 10 scores over there because there are 10 different categories. And here I'm just going to try a simple example. The fashion items, it will be a bit more complicated. So given that we're just using a very small model over here, I simplify the problem to basically just identifying digits rather than identifying fashion objects. So we have digits over here that can either be 0, 1, 2, 3, 4, all the way to 9. I think anybody can tell that this is going to be a 7. What we are trying to do is that we're trying to train the computer to identify that this is going to be a 7 over there. Okay, and so what I want to do is we can just go ahead to try an example. So what I want to do over here is I'm just going to share on the chat box the Excel, the completed Excel spreadsheet. And so you will then be able to go about to play around with it. Okay, but let me just open it up as well so that I can share it with you guys. So if anyone has problems downloading that Excel spreadsheet from the chat box, let me know, but I'm assuming it should be fine. Meanwhile, I'm also waiting to open up my Excel spreadsheet just to illustrate that to you. Okay, and now I'm basically just going to share my Excel spreadsheet. So this is the one that you should have downloaded over here. So essentially what we have over here is that we have our input scores over here. So this is your input layer. And then later on, we have our hidden layer over here. And finally, we have our output layer over here, where essentially we have a score associated with each of that image. And here you can see that the score associated with 7 is going to be the largest. And so the prediction is that this image over here, it's going to be a 7. And indeed, it is a 7 over there. Okay, I have provided 3 other images over here. So if you go to image 2, you can just go ahead and copy image 2 over here. You can just copy it, and then you come to classification over here, and then you just paste the values. Just go ahead and paste values, and then you realize that in this case, image 2 is going to be, it looks like a 1, right? And so if we just quickly scroll down over here, you realize that the scores have all been updated. And in this case, 1 appears to be the one with the highest score. And so the prediction is that this image is going to be a 1 over there. Okay, and so this is just a quick sharing about what we're going to do after we come back from the break. But before we go into that, let me just, I shouldn't have done that, right? So let me just share once again my PowerPoint, just to get you guys to think about it a bit more. Which is that there's a well-known problem. A well-known problem is that unfortunately, it's going to be very simple to fool machines over there. So we are using what I've taught you. It is possible to train machines to be able to identify that, okay, this is going to be a stop sign. That is going to be a no crossing sign and so on. But the problem with machine learning is that we could actually just make very small changes to our image over there, and suddenly the machine learning, our machine is then going to perform a wrong classification over there. Okay, and so one thing that you can try to play around with is also that the classification model I shared with you just now, you can try and change some of the numbers over there. Okay, and so let me go back to the 7. So you realize that, let me see, this at this point. So let me come back to my Excel spreadsheet. Okay, you realize that at this point in time, the score for image 0 is going to be 3.4 over there. And so if I was to basically change the numbers over here, you realize that the score for 0 increases to 3.7 over there. Okay, and so by playing around with the numbers over here, you are going to have the influence over the score over there. Okay, and so that was something else that you can try during the break as well, which is that, are you able to basically just change some of this value such that a normal human will still recognize that image as, let's say, a 7, but then the computer will result in a wrong classification over there. Okay, I probably have gone on for quite a while. I think this is a good time to take a break. So let's take a 12 minutes break, and let's get back at 11:30, where we're just going to quickly run through on how you can do this Excel over there. Okay, so let's take a 12 minutes break, and let's come back at 11:30. Meanwhile, if you have other questions, feel free to just type them into the chat box, and then I'll be happy to address them after we come back from the break. Okay, the time it's 11:30, so let's continue. So welcome back from the break over there. So very quickly now, let me just come back to my example over here. So this was where previously we highlighted to you that we have an image 7 over here, and our classifier basically resulted in the highest score for the image 7 over there. So our prediction is going to be 7. The question over here is, are we able to make some small changes to this image such that we will make a wrong prediction? Okay, and it's actually not too difficult. So you can play around with the numbers. So let's say now this is 11 for 7, right? You realize that 9 and 3 are going to be somewhat having higher scores as well. So if I change this instead of 0 to 255, then this is where you, and then let me do the same for over here as well. And let me just paste this. Let me just do this. Okay, so let me just change all these zeros into 255, that's all. Okay, so to a normal human person, this is just going to look like random noise. Okay, so you are just going to ignore this and then you say that, hey, this looks like a 7 over there. But if you were to look at our image classifier, basically now our image classifier is going to say that, oh, this image actually looks like a 3. So this whole thing over here looks like a 3 more than it looks like a 7 over there. I mean, if we were to look more in depth into the scores, you realize that the image classifier says that 3 and 7 are both going to be likely possibilities over there. But if you simply went with the highest score, then it's just going to say that it's a 3. Okay, and then that's where it results in a wrong prediction over there. And that's what the article just now was saying, which is that essentially it's not too difficult to trick a machine learning classifier, because the machine doesn't really know what is a 1, what is a 2, what is a 3, and so on. Okay, and so basically to it, it's just a series of numbers. I take in a series of numbers, I perform the calculations, I output the scores over there. Okay, and so this is where when we implement such technologies, we do need to be careful. Okay, and I hope this is where it becomes clear as well that perhaps we shouldn't just be looking at the largest score, but then we might need to look at, what are the other scores over there. But once again, then in terms of the implementation over there, it is going to go beyond sort of like this very conventional machine learning framework, where basically we just output a score and say that this is going to be the most likely type of prediction over there. Okay, the manager will then need to balance between the risk. What is the consequence of making a wrong prediction over there, or making a wrong classification? What are the remedy steps that we have in check to make sure that in case an error happens, we're able to rectify it and so on. Okay, that goes beyond machine learning. Okay, with that, I think the next thing that I want to do is that I want to basically run through the quick example that we have. I've already shared with everybody the blank template. So just open up the blank template, and let's just go ahead and use that. Okay, so let me just share this blank template now. So if you are great at Excel, perhaps you might already have figured out everything, and that's fine. But if not, then feel free to just follow along with us in terms of how I actually populated that particular template over there. Okay, along the way, any questions? Once again, feel free to just drop me a message on chat, and then we are going to address it. Okay, the first thing is we want to actually just paste the image onto this blank one over here, right? So let me just go to this sheet over here, and I'm just going to select these. I'm just going to copy. I'll use Control-C. Of course, you can also use this copy button over here, whichever works for you. I just use Control-C, and I'm just going to right-click, and I'm just going to paste the values over there. Okay, you could just go ahead and paste, that's fine, but it basically messes up the formatting over there. Okay, so just paste the values so that the grids remain over there. Okay, the next, so I hope everyone can follow this. Okay, so while I wait for everybody, basically just to highlight that later on, we're just going to use 16 numbers, and we're going to use the average of each of this grid as each individual number. Okay, and so that's how we make use of just 16 inputs rather than 784 inputs. Okay, so visually you can already see that 7 over there, but if you want the colors, what you need is going to be conditional formatting. Okay, so just go ahead and select all the 784 cells, and then just go ahead and click on conditional formatting. It should be under your home tab over there. Okay, so under conditional formatting, you can just go ahead and choose color schemes, and you can just go ahead and choose whichever you want. Okay, the one I used in the example just now was this green yellow color scheme. Okay, so once again, to get the color, basically you just want to go up to conditional formatting over there, And under conditional formatting, you just you will be able to see a lot of options. Choose color schemes and choose whichever color scheme that you like over there. Okay, green, yellow seems to work well. And so that's basically the one I chose. And so basically what it does is that based on the number, based on the value of the cell, is going to decide on the color intensity. Small values are going to be yellow. The large values are going to be green. And any values in between is going to be some color between yellow and green over there. Okay, and so this is going to be the first step. In case you have problems following, I basically just provided this template that already has that already. But if you're able to get this, then no problem. I just prepared that as a standby in case we have people who are having difficulties following. So I'm running a one-man show over here. So in case there are problems, I might not be able to provide personalized tutoring for that specific step. So if that helps. Okay, but if there are any questions, feel free to just type them. If not, I'm going to assume everything is okay. Okay, and once you have that, the next thing that we want to do is we want to get our input values over there. Okay, and as mentioned over there, rather than using 784 numbers, we only want 16 numbers. And so how we do that is that for number one, for input one, we're basically just going to use the average of all the numbers in this square over here. Okay, this 7 by 7 over there. I believe it's 7, right? 2, 4, 6, 7, yes. Okay, and so that turns out to be 0. Not surprising because all the values over here are going to be 0. For the second one, it's just going to be this one over here. Okay, so this is the formula I have, the average, and then I choose these cells over here. So this is going to be the first input, second input, third input, fourth input, fifth, sixth, 7, 8, 9, 10, 11, 12, and so on. Okay, I'm assuming this should be okay. And if that's okay, I'm just going to quickly just do that as well, just to demonstrate to you that it's not too difficult. Of course, your speed will depend on your familiarity with Excel over there, right? And let me just share with you the next one. This is step 3 over there. In case you're having problems following, then you can just make use of that third template that I have shared with you over there. Okay, but this is just to demonstrate to you that it shouldn't be that bad. Okay, once you're familiar with Excel over there. Excel is actually very useful. So I do teach a year 1 module, and I teach our students Excel skills because it's a very good tool for you to implement a lot of these decision support tools. For example, you know, if I have an image, this is an example of a decision support, right? That if I have an image over there, are you able to give me a prediction as to what it's going to look like over there? Okay, and so then this is going to be 11. So as you do this along with me, you can just basically just double check to make sure that the values that you're getting is going to be correct as well. Okay, and if there are any questions or if you spot any issues along the way, feel free to let me know. So those of you who are familiar with Excel, you might be familiar with Excel VBA. You can even do a bit of coding to just automate this whole process rather than manually putting in the 16 numbers over there. Okay, but then again, sometimes if it's just 16 numbers, it's probably faster for you to just manually just you know, type this out rather than for you to do a VBA code to go about to do that. Okay, and so, but of course, if you have a lot of these repetitive tasks, then it makes sense to do a bit of VBA for that. Okay, I'm not seeing any questions over there, so I'm assuming everyone is good. Everyone is able to get these inputs over here. And with the input value, so now we already have our 16 inputs. The next thing that we want to do is that we want to actually calculate out the values that are going to be in our hidden layer nodes over there. So recall just now I say that we're going to have 12 nodes, and so that's why I'm going to have 12 numbers over there. Let me just bring it across over here. So how are we going to get the numbers? So in the first node, what happened is that it's going to be the input value 1 multiplied by that connection weight, plus input value 2 multiplied by that connection weight, plus input value 3 multiplied by that connection weight, and so on. Okay, and so all the way to input value 16 multiplied by its connection weight. And then later on, I'm going to add the bias values, which is this one over here. So here I have a temporary column. This temporary column basically is just for me to do this multiplication, this times this plus this times this plus this times this, and so on. The way that you can do this in Microsoft Excel is to use M multiply. Okay, MMULT over there. If you're familiar, it basically stands for matrix multiplication. Okay, you're just going to perform a matrix multiplication of two vectors over there. Okay, so just go ahead and type MM multiply. And then basically for your first input, you just want to select these cells over there. Cells from AL all the way to BA, because these are going to be the connection weights. And then I put a comma over here. And then I'm going to multiply by my input values over here. Okay, the next, later on, what I'm going to do is that I'm just going to copy and paste it going down. Okay, and so this is where Excel later on, we want to make sure that this row continues to move down, which Excel will do, but we do not want this column over here to move down as well. Okay, and so for us to do that, we need to tell Excel that later when I copy, I want you to continue to remain at AG4 to AG19 over there. To do that, basically you want to put in the absolute referencing. We can do that by just basically pressing F4 over here. You realize that there's going to be a $ in front of your AG and your 4 and your 19. Okay, this basically means that later on when I copy and paste, it's not going to move down. Okay, if you're having problems with the F4, you can also just manually go ahead and type it in over there. Okay, it's not going to be difficult. So let me just do that again. M multiply. I'm just going to select this row, and I'm going to select this column over here. And then I'm just going to do this multiplication. Okay, what I can do is that I can just come back over here and manually just type in my $ in front of my AG, my 4, my AG, and my 19 over there. Okay, so either way is going to work. And once you have that, you can just go ahead and copy. I use Control-C, and then I paste it down here. Okay, either way that you like to do your copy and pasting. For me, I just press Control-C, then I hold on to Shift, I press down to select the remaining cells, and then I just press Enter to get that in over there. Okay, let me just, and then for the values over here, the value essentially is just going to be this temporary value plus my bias value over here. Okay, but then you realize that it's going to be a negative number. Recall that for this example, I want to just convert all negative numbers into 0, that's all. And if it's a positive number, I leave it as it is. So for us to do that, basically, we can just use a max function over there. I use a max 0 or this value. So if this value is a negative number, I'm going to return 0. If it's a positive number, I'm just going to return that number over there. Okay, and with that, this is what your output should look like. And let me just send you the file with this step. So this is going to be step 4 over here. Okay, and once we have this, the next thing that I want to do is I want to repeat this calculation. So this is going to be the neuron values in my hidden layer. And so I want to then use this as inputs to compute the score for my output layers over there. So I'm just going to repeat everything the same as well. So this time around, I'm just going to copy all those neuron values in the hidden layer over here. And so this cell, should essentially just contain the value that is in this cell over there. Okay. And so then I'm just going to copy and paste this down over here. So essentially you realize that this number over here is essentially the same as this number over here. Oops. Okay, I'm just copying these values over here, that's all. Okay, you just put equals to that one above there. And then this next step over here, essentially is just going to be exactly the same as what we did just now. Okay, so this is a revision of what we did just now, right? So it's just going to be equals to m multiply. I'm just going to multiply this row by this column over here, where I set it to be absolute referencing so that later on when I copy and paste, it's not going to give me any issues. Okay, and here is basically, I'm going to return the value of my temporary value plus that bias value. If it's positive, if not, I return a 0. So that's where I use a max function. If it's negative, I return 0. If it's positive, I just return that value over there. Okay, and with that, then this is what your output should then look like. Okay, let me just probably leave it at this function in case you need to see what the function is. And let me just share with you step 5 of this. Okay, and with that, we basically reached that last stage over here, where this essentially is our output layer already, right? So these are our output scores. So let me just do the same as well. So the score for image 0 is just going to be 3.4. And the score for image 1 is going to be 2.8, image 2 is going to be 1.6, and so on. Okay, and so from here you can see that the image with the highest score is going to be 7. Okay, so I mean, we could just leave this, right? And leave it to our user to figure out which is the largest score and then figure out that 7 is going to be that prediction over there. Of course, if you want to automate this as well, it's not too difficult. So for you to do that, the first thing we do is let's use the max function again. Let's find the largest number out of these 10 scores over there. Okay, so it's just basically max of these 10 numbers over here. And this is where it's going to return 11, which is the largest of them all. And the final piece to your image classification is basically a VLOOKUP function over there. So what does VLOOKUP do? We're going to tell VLOOKUP to try to find this value along this column over there. Okay, so try to look for 11, which is in this cell, along this column over there. And after you found 11, return whatever value it's next to it. So that's what VLOOKUP does. Okay, it's basically short for vertical lookup. We are looking it up in a vertical direction. So VLOOKUP, what value do we want to look up? We want to look up for this value, which is 11. Where are we going to be looking up this value? We're going to be looking up this value along this column over here. I selected the 2 columns because later on I want them to return what is in the second column. Okay, so look up 11 in this array, and once you find 11, return the value that is in the second column. Okay, so this is flexible. In fact, you can return the value in the 3rd column, 4th column, and so on. Okay, so but in this case, I just need to look up this value and return the value that is in the 2nd column. And finally, basically it asks, are you okay with an approximate match, or the match must be exactly correct? So in this case, we know that there's always going to be an exact match over there. So let's say that we want it to be exactly correct. Okay, and so this is the last piece for your image classification, where basically you use a VLOOKUP. We know that the largest score is 11 already, so look up for the score 11 and then return the image that is associated with that score. And there you have it. So essentially this is going to be your image classifier, where you are able to compute the scores based on the 16 numbers that we have over here. Okay, so these 16 numbers is not really our image, right? It's going to be a condensed version of our image over there. We have an image over here that we split into 784 pixels. But of course, if we have 784 columns over rows over here, it's going to take us very long just to do that averaging, right? So sorry, in fact, we don't need to do the averaging, but you need to do the multiplication, which gets complicated. But yeah, so that is why I basically just simplify it into 16 images over there. For this classification problem, we can do that because it's a fairly simple classification model. So a simple model like that with just 16 inputs, even though it's just a condensed form of the original image, it actually works pretty well. So you can go ahead and try with the other images as well. They should return you the appropriate prediction over there. Okay, so I think I've done my job in terms of conveying this to you. I hope everybody is able to follow, but of course, if you have troubles following, basically, I've given you the 6 of these files already. You can just follow step by step. I hope that should be able to allow you to figure out how this can be done. If you still have any questions, always feel free. You can just drop me an email, no problem. I'll be happy to just address them if ever you have any questions over there. Okay, I've basically just shared my email on the chat. So if you have any questions, feel free to just drop me an email. Okay, so that is essentially what I have for you all. Is there any questions or any clarifications that you want to check with me? I think we still have a bit of time. We have 7 more minutes. So if you have any questions, feel free to just shoot them. If not, if you are done, feel free to also just leave if you are rushing off to somewhere else. It's a Saturday, I understand. Oh, okay. How to find the weight and bias values, right? So just now we mentioned that basically we use historical data like 60,000 images to figure out what are the weights that are going to best fit it. So I hope you can see that this is going to be an optimization problem, which means that what combination of weights and bias values is going to get us that particular value over there. So very quickly, let me just, so for you to do that, unfortunately, you will not be able to use Excel for that, simply because Excel is able to perform optimizations, able to solve simple optimization problems. But for more complicated optimization problems, it's going to be challenging over there. And so to tackle that, you are going to such complicated optimization problems, you need a more sophisticated type of optimization solver. And for this particular example, how I did it was basically I used TensorFlow from the Google Colab over there. I mean, from the Google. So let me just try and see if I can pull up the TensorFlow website, and I'll just share that with you. Okay, and so this is where finding the optimal weights and bias is going to be requiring a stronger optimization engine over there, which unfortunately Excel will not be able to take care of, and we will not be able to cover it in this class as well. So, but then, you will be able to find out more in terms of TensorFlow over there. So I've shared that link with you. Okay, yeah. And so one thing that is worth noting over here is that for TensorFlow, essentially their optimization problems or engines is catered specifically for machine learning type of problems. But more generally speaking, actually a lot of different problems are going to be optimization problems as well. So you could have a scheduling problem, you could have, let's say, a shortest path problems. Okay, and so there are different types of solvers that can solve for those. And if you know how to express them mathematically, then Excel can also potentially be used to solve a smaller version of that. Okay, but once you have, let's say, the weights and biases, then you will be able to make use of Excel to implement this image classification over there. So I think it's important because at this point in time, very often we have people who basically just show the company that, hey, you can use Python to do this, right? But then at the end of the day, none of the employees at the company know how to do Python. Okay, so with this, we don't really need Python, right? So if I want to implement, let's say, some machine learning type of technology, all I need is actually the weights and biases. I can put them into Excel, and then essentially Excel can then go ahead to perform their prediction over there. Okay, so in practice, we're not just limited to in terms of, let's say, image classification. The company might be interested in predicting demand next week. It's the same idea as well. We can put in historical demand, and then we try to predict what the future demand is. We're just inputting in numbers, and we're just coming out with a number over there. Okay, and so I think that's where Excel skills are going to be important as well, because not only are you able to solve the problem, you need to convert your solution into a particular format that the company is able to use over there. Okay, so that is a good question. That's a good point. I haven't covered about sort of like how you can actually obtain it. Yeah, unfortunately, it's beyond Excel's ability to figure out what is the optimal weight and bias. Great. Any other questions? Okay. Are there any other sections covering optimization? I I am thinking potentially. So I think the optimization will be interesting, and we do hope to do a workshop to cover it. Probably just a bit of advertising as well, that our student club is organizing a case competition, which they are going to be holding it in February. I believe that more information will be out soon. Once it's out, we will share with our school contacts. But at the same time, do follow. If you are interested, also you can just follow us on our students club Instagram, and that information is going to be there as well. Okay, so why I'm saying that is because for the case competition, there will be a workshop. So I do not know what their problem is. If it's an optimization problem, then they will conduct an optimization workshop over there. So usually we are not going to do a machine learning one. So there's a lot of these machine learning competitions out there already. So so that might be one place where they're going to do a workshop. Okay, so that we have to wait to see what their competition is about. I've put in their Instagram page over there. So they haven't talked about the case competition yet, but I think closer to once the details are out, then they will be releasing it. So do keep a lookout for that via their Instagram page. And there will be a workshop associated with it. So that could be optimization, or it could be simulation and so on. But I think, yeah, in the longer term plan, we also plan to have workshops on optimization and simulations, which we think are going to be very helpful. Basically, they are the tools that our students use to help companies solve problems. And the feedback from companies have always been that these are essentially the type of skills that they need. Yeah, so I hope that answers your question. Unfortunately, I'm not able to give a direct answer now, but yeah, follow them in terms of their case competition and see what their workshop is about. Thanks for the kind comments. I think this is an interesting topic, so I'm glad to share. Okay, great. I think it's 12 p.m. If there's nothing else, please feel free to just log off and enjoy your weekend. I'll hang around for a few more minutes just in case there are any lingering questions. If not, then yeah, enjoy your weekend and enjoy your holidays. Take care. Thanks for the kind comments. Okay, may I know how is the value in green derived? Oh, okay. So basically we're just using conditional formatting, that's all. Okay, and so this was where we did it. So this is a conditional formatting run. And so you just go conditional formatting and then just choose the color scales, that's all. Okay, so I hope that answers Stephen's question on how the values in green are derived. If that's not what you're asking, then feel free to clarify. What is my PhD on? My PhD is actually on optimization under uncertainty. Let me see. Is that on my webpage? Yeah, probably. Yeah, my PhD is on decision making under uncertainty. I do have a web page where I put out some of my publications, but of course, there's a link also to the Google Scholar where you can see all my papers. So yeah, if you're interested, you can just check out those papers, or you can always just find out more. Or you can always just email me. I'll be happy to share more. Let's see. How do we get those numbers? 84 and so on. Oh, okay. So basically what we do is that basically, let's say we have a photo over here. And so for that photo, what I do is I just cut them into 784 different pieces. And then we run a computer algorithm to say that, okay, what's the color? And then for that particular color, we associate that number over there. Okay, and so that's how we get the numbers 84, 185, and so on. We take a photo, and then that photo, we split them into different pixels. And then based on the pixel, we will assign that number. So that's how we actually get all these raw image data over there.